guys, so in this video I want to do a quick overlay of scatterplots and lines of best fit. So kind of a quick overview of all the topics that are talked about in this unit. So first off, we do have a scatterplot. The goal of a scatterplot is it allows us to represent a data point that both has an x and a y value. So an x and a y value that are tied together. So every single point in this scatter plot is tied to an x and a y value. So the way you hear that is bivariate data is the name that comes up. But basically, we're going from data sets that just has one single variable to now two variables, x and y data. Okay, so when we're looking at these, your x is going to be your independent variable, y could be your dependent variable. Another way that we've seen it is x is your explanatory variable and y is your response variable. So we're going to tweak around with x and change x and see what kind of response we get from y. So explanatory and response, or independent and dependent. So we're affecting x to see how it changes y. So when we look at scatter plots, what we want to look at is we could describe it and we could talk about its strength, direction, and form. So when we're talking about strength, we're talking about when we plot all these points, do they kind of cluster tightly together or do they really space out? When they're tightly clustered together where you can kind of see the pattern there, that is very, very strong strength. Where when things are really, really spread out and you're not really sure what's going on, that's more of a weak strength. Direction, we're worried about as x increases, so as we go bigger and bigger and bigger on the x-axis, on the y-axis, are we getting bigger or are we getting smaller? So as we go along the x-axis, what's happening on the y-axis? So if I kind of trace this, as x gets bigger, it might be easier with two items here. As x gets bigger, notice y is coming down on the axis. So this would be a negative. So as x gets bigger, because moving bigger this way, y is getting smaller, which is coming down this way. So as x gets bigger, y gets smaller. We could also talk about it going in a positive direction, which that would be, hey, as x gets bigger, y gets bigger. Kind of a deal there. Form is just kind of what do you see? Does it look linear? Does it look quadratic? Does it look exponential? What does it look like? For all purposes of what we are doing in a college level entry stat course, we pretty much look at linear. There are other forms out there that we can explore, but a lot of our focus is on linear. So once we have a scatter plot, we can describe it, yeah. What else can we do with it? So this is where the line of best fit comes in. And you might hear me call it a line of best fit, saying I did a linear regression or a least squares regression line. They're all three the same thing. Line of best fit, linear regression, least squares regression line. They're all talking about how I fit a line to my data. So you see, I made some random scatter plot here of x and y's. There's all my points. And then I fit this red line to the data, okay? Now, the purpose of this line is we can come up with an equation for it, which is represented by y hat equals a plus bx. The point of this equation is it allows you to make predictions, because we would really like to kind of make predictions of what is going on. Stats is really trying to understand the world around us. So collecting data on the world around us and better understanding it. So in this case, if I can collect data, x and y, and I make a scatter plot and I come up with a line of best fit, I can make predictions on what I think will happen. So if I had like an x value of 22 or so, it looks like my y value is going to be right around 100. And I don't know what x and y stands for. I just made a very loose example here. Okay, so most importantly, the line of best fit, its purpose is for making predictions. So when we look at this equation, two pieces that we're going to look at. The first part is your y-intercept, and whatever is in front of the x is your slope. Now, this is a little bit different from what you saw in Algebra 1, y equals mx plus b. It's a little bit flipped around. So y-intercept comes first, slope comes second. So an example of what an equation we might see is y hat equals 32.7 plus 2.23x. So if this was my equation, and I wanted to know what is happening when x is 25, I could plug the x of 25 into this equation and produce a predicted y value, hence y hat, okay? So we can produce a predicted y value. When we're looking at this equation, some important features that we need to know is interpreting y-intercepts and interpreting slopes. So y-intercepts is the y value when x is 0. So you would want context here. So if x is number of hours studied and y is the score on some sort of test, you would say, hey, if the y value, so I'm going to score this much when my study hours is 0. So if you study 0 hours, I'm going to get this score on the test. If I used study hours for x and score for y, if I use that. For slope, that is as x increases by 1, y will increase or decrease by whatever value that slope is. Now, the reason why I say increase or decrease is if your slope is positive, you're increasing. If your slope is negative, you are decreasing. Okay, so going back to my same example of hours studied and say a score on a test. So as the number of hours that I study increases by 1, my score on the test will increase by whatever my slope is, if it's a positive slope, or my score will decrease by this many points if it was a negative slope. So we'll have to know how to interpret y-intercepts and slopes. Another kind of layer with coming up with a line of best fit is, yes, we know how to do it by calculator, but we could also do it by computer output. And I don't want to write out a full computer output. The important pieces that you should be looking at whenever you look at a computer output, you're going to see a column that's labeled coefficient, and then 2 rows. One is labeled constant, and one is going to have your label of whatever your x variable is. So if our x variable, again, let's go back to that example of number of hours studied, you would see number of hours studied here, and you would see 2 numbers. The thing that you have to figure out is which number is your y-intercept and which number is your slope. The row that has your constant, that is going to be your y-intercept, and the row that is tied to your x variable is your slope. So y-intercept first, slope second, which kind of helps you out because y-intercept is first, slope second in the equation. Okay, so we do need to know how to pull that information out as well. Final thing I want to talk about is, yes, scatterplots, line of best fit allow us to make predictions, but there's one thing we need to be careful about, and that is extrapolation. Okay, extrapolation. So this is why I had this example up here. I could definitely predict what's going to happen when x is anywhere from like 0 to about 35 or so, because I have enough data all around all those x values. What extrapolating is if you wanted to predict what is happening when x is like 50, okay? We could totally predict what's happening when x is 50 and say, all right, we should be around a y value of 200. But the reason that's a bad idea is we really don't know what our data is going to do out here. You're making a prediction outside the scope of your data. So our data really goes from an x is 0 all the way up to an x is about a 35 or so. So predicting all the way out here when x is 50, not ideal. Okay, that is extrapolating. We don't know if I continued on collecting data, is it going to go upwards? Is it going to go downwards and flatten out? Or is it going to keep following this trend? We don't know what the trend of the actual data is out there. So it's not a good idea to make predictions outside the range of your data. Okay, so that is extrapolation. You can totally make the predictions. You're just going to have to take those predictions with a grain of salt, because sometimes we just need to make predictions and say, hey, I think this is going to happen, but just understand we could be wrong. Okay, so this was a general overview of scatterplots, how we talk about them, what we can do with them as far as finding the line of best fit and make predictions, and some of the smaller details you need to worry about. Computer outputs, y-intercepts, slopes, and extrapolation. I'll make one more video that goes a little bit further on some of these details, but this is your general overview on scatterplots and lines of best fit.